At that precise moment, 3I Atlas drifted past Mars. Something unusual occurred. While most Earth-bound telescopes focused on tracking the comet, China's Tianwen-1 turned its gaze outward and detected a startling shift in color. The familiar progression of white to yellow to emerald vanished almost completely, replaced by a deep, throbbing red. A heat signature unlike any known comet radiated from its core. That single observation may represent the first evidence that 3I Atlas is more than just a comet. It appeared to be waking up, and the world had yet to notice. Tianwen-1's unexpected adjustment. The spacecraft wasn't designed to hunt interstellar phenomena. Its instruments were intended to map Mars' surface, atmosphere, and climate dynamics. Yet, in early October, as 3I Atlas approached Martian orbit, mission operators quietly repurposed one camera to scan the sky beyond Mars. The result defied expectations, a color transformation unseen from Earth. In that brief observational window, the camera captured Atlas glowing crimson, where earlier measurements had shown pale white transitioning through yellow and green. Now, the comet radiated a deep red light, pulsing with a slow, rhythmic intensity. The effect was too precise to be a sensor error. Cross-referencing with Earth-based spectral readings revealed infrared excesses, faintly detected before but never in such clarity. The red core, imaged at high resolution by Tianwen-1 spectrometer, indicated internal heat generation rather than passive reflection. The emission lines corresponded to ionized carbon and metallic vapors, not dust scattering or organic fluorescence, resembling an internal reactor in operation. That single image altered the narrative. What had been considered a distant, inert comet now behaved like a machine. If 3I Atlas had indeed self-activated, Tianwen-1 may have witnessed its first ignition. The question remained, was this a new phenomenon, or had the red glow always existed, unnoticed until observed from Mars? Spectral surge and thermal power. Raw telemetry from Tianwen-1's infrared spectrometer stunned operators. When the data reached Beijing Aerospace Flight Control, analysts anticipated faint, scattered readings from a cooling comet, small peaks from water ice, dust, and residual CO2. Instead, jagged spikes erupted across multiple wavelengths, signaling rapid internal heating. Surface temperatures were estimated above 5,000 degrees Celsius, nearly 10 times higher than expected for a comet at Mars' distance from the Sun. Initially, engineers suspected calibration errors, but repeated checks confirmed the anomaly. Rhythmic, intensifying spikes every 9 hours, matching Atlas rotation period. The heat was synchronized, not random. Comparing these readings with ground-based infrared data from the Atacama Desert showed a CO2 emission band at 4.26 microns, consistent with engineered plasma exhausts. What alarmed scientists was the precision. Narrow, sharply defined emissions, unlike natural thermal radiation. Tianwen-1's visual imager captured further anomalies. During the thermal surge, the comet's halo shifted color frame by frame, green fading to amber, then deep crimson. Algorithms designed to filter solar reflections could not account for the progression. It was not a passive reaction to sunlight, but resembled a controlled thermal sequence. Analysis of the full data packet revealed the chemical signature, nickel vapor lines, created only at temperatures above 3,000 degrees Celsius. No natural comet could vaporize nickel in cold Martian orbit. Repeated spectrometer checks confirmed these results. The presence of ionized nickel gas implied active metal vaporization. Natural heating could not account for the steady thermal curve. Even massive outgassing would be chaotic, yet Atlas vented with surgical regularity. Scientists reached a shocking conclusion. The emissions appeared mechanical. Nickel alloys are standard in plasma and ion engines because of heat endurance. Firing such engines releases nickel vapor mixed with CO2, exactly what Tianwen-1 detected. Ratios of nickel, CO2, and silica dust mirrored those from early Mars orbiter thrusters. Debates erupted. Was Atlas expelling exhaust or regulating internal energy through thermal cycling? Either way, this was beyond any comet previously observed, active, deliberate metal vaporization in open space. Tianwen-1 had captured a phenomenon producing heat, not merely responding to it. Pulse pattern and self-regulation. Overlaying thermal curves with time-stamped imagery revealed a pattern. Each heat spike coincided with a faint flicker in the red glow, a heartbeat of energy repeating with machine-like precision. 12 rotations confirmed the pattern. Intervals of 9 hours, 4 minutes, and 32 seconds. Natural comets erupt randomly. Atlas followed a precise schedule. Intensity ramped, plateaued, then declined symmetrically, resembling a controlled power cycle rather than melting ice. Frequency analysis revealed harmonic overtones, secondary peaks matching controlled plasma oscillation behavior. Even Tianwen-1's magnetometer, not intended for deep space, detected subtle, synchronized magnetic disturbances during each pulse. Atlas was not only hot, it was electromagnetically active. Analysts noticed that each pulse grew stronger with increased solar wind density, suggesting Atlas absorbed solar energy and released it in quantized bursts. Avi Loebo's Harvard team described it as a timeline of power: activation, reflection, absorption, ignition, and regulation. Feeding effect and rising mass. As Atlas moved past Mars, gravitational models and observations indicated it was gaining mass, not losing it. Initially estimated at 10 billion tons entering the inner solar system, mass tripled to over 30 billion tons during the red phase glow. Radar and gravitational interactions confirmed the density increase. Nearby dust streams bent toward Atlas. Spectral readings revealed charged silicates and magnetized dust grains, behaving contrary to typical comet physics. Chinese scientists hypothesized Atlas was harvesting material using electromagnetic confinement, drawing dust inward, potentially compressing or fusing particles for energy. Tianwen-1 documented what resembled a self-sustaining metabolic process, a cosmic probe converting ambient material into fuel, recharging as it traveled. Magnetic envelope. Tianwen-1 detected faint, structured oscillations in its communication band, synchronized with a 9-hour thermal cycle. These disturbances did not align with solar flares or galactic sources. The pulses suggested a magnetic envelope surrounding Atlas, extending thousands of kilometers. The field oscillated in a repeating lattice of polarities, possibly generated by a rotating internal dynamo. Natural comets' magnetic fields are weak and ephemeral. Atlas field persisted for weeks, intensifying with red glow pulses. The envelope might shield internal systems and trap charged dust for absorption as fuel. Chinese data leak. For 2 weeks, Tianwen-1 operators remained silent. The red phase data was politically sensitive and extraordinary. Then a 14-megabyte file surfaced anonymously on Weibo Science Watch, tagged T1A. Within hours, it spread to forums frequented by amateur astronomers. The file contained compressed telemetry, partial infrared scans, and an image from Tianwen-1's optical payload, October 14, 2025, 3:02 Universal Time Coordinated. The image showed a red sphere encircled by concentric rings, faintly flickering between visible and infrared. A smaller object appeared tethered by a red filament. Metadata caption read, Frame 119 Internal Activation. Within a day, the leak went viral. Western observatories confirmed coordinates near Mars' orbital plane. NASA refused comment. The Chinese Academy of Sciences called the image a fabrication. Raw spectral data, however, showed consistent CO2 and nickel peaks, alongside an EM feedback signal delayed by 22 seconds, suggesting Atlas responded to Tianwen-1. CNSA internal debates revealed a split. Younger scientists wanted publication, veterans feared escalation. Meanwhile, global observatories began discrete monitoring. Vera Rubin Telescope in Chile detected red flickers matching the 9-hour cycle. ALMA in Japan reported faint magnetic scattering. Official statements attributed anomalies to natural causes, but no explanation covered the 22-second EM delay. Second activation near Jupiter. By late November, Atlas entered Jupiter's gravitational zone. No interstellar object had survived this far intact. As it approached the gas giant, its brightness intensified, deepening to scarlet. Within a single rotation, red light surged tenfold. Paranal observatory sensors recorded an infrared spike forcing temporary shutdown to prevent damage. Energy output exceeded 50 gigawatts. Tianwen-1 captured magnetized plasma streaming from Atlas, expelled in precise symmetry, perpendicular to its trajectory, behavior consistent with controlled maneuvering. Predicted paths shifted slightly. NASA confirmed a 1.2 kilometers per second velocity adjustment. The thermal surge and trajectory change matched observations. For theorists, this confirmed intentional, mechanical activity. Final phase and global silence. In early hours of December 12, observatories worldwide reported Atlas red radiance vanished, replaced by faint white, similar to initial detection. Analysts noted active deceleration. Relative velocity dropped nearly 2%, impossible through natural forces alone. Tianwen-1 recorded a final broadband low-energy signal echoing the 9-hour cycle, stretched and fading like a dying heartbeat. Spectrogram analysis revealed fractal geometry, repeating nested bands too precise for noise. 2 hours later, the transmission ceased. The comet dimmed, blending into background starlight, and by the following night, it had disappeared entirely. The aftermath and global tension. Following Atlas' disappearance from sight, the scientific community was left grappling with questions that had no precedent. How could a single object demonstrate coordinated thermal cycles, active mass accumulation, and electromagnetic control, then vanish so quietly? Across the globe, observatories shifted into a cautious state of vigilance. Every optical and infrared telescope capable of deep space monitoring was realigned, not only toward Atlas' projected trajectory but also toward nearby regions where its gravitational influence might have drawn debris. Analysts combed through prior observations of interstellar objects, searching for patterns they had previously dismissed as anomalies. Was it possible that other comets had shown similar activity, their subtleties lost to insufficient instrumentation or observational bias? The political implications were immediate. Governments with spacefaring programs quietly convened emergency briefings. From Beijing to Washington, Brussels, and Tokyo, agency directors debated the balance between public disclosure and national security. If 3I Atlas was truly behaving like a self-activating machine, the implications extended far beyond astronomy. Engineers and astrophysicists considered the object not only as a scientific anomaly but as potential evidence of advanced extraterrestrial engineering. Questions of intent, origin, and capability dominated internal discussions. Was this a natural cosmic quirk, a misinterpreted interstellar body, or a deliberate artifact designed for long-term operation in the inner solar system? International collaboration, for the first time, became both necessary and tense. Communication channels opened quietly between NASA, ESA, CNSA, and JAXA, but the exchange was formal, limited, and laced with suspicion. Each agency understood that any misstep in analysis or disclosure could ignite global speculation or panic. Yet behind closed doors, data flowed. Tianwen-1's archived images and spectral logs were shared selectively with trusted partners, alongside cross-references from Earth-based observatories. Preliminary analyses confirmed the extraordinary findings: pulsed heat cycles, red-phase spectral lines of ionized nickel and CO2, and evidence of a magnetic envelope extending thousands of kilometers. Even seasoned scientists struggled to rationalize the scale and precision of these phenomena. Amateur astronomers also played a crucial role. With the leak still circulating online, thousands of independent observers scanned prior archives. Small telescopes across Chile, South Africa, and the Canary Islands were mobilized to cross-check any faint signatures in previous comet observations. Data overlays revealed previously unnoticed correlations in other interstellar objects' light curves, though none matched Atlas' level of sophistication. Discussions on online forums ranged from cautious hypotheses about plasma physics to outright speculation about extraterrestrial probes. Social media amplified both curiosity and fear, and mainstream news outlets began reporting on anomalous comet behavior, careful to frame the events as under investigation rather than confirmed alien activity. Back in orbit, Tianwen-1 continued its surveillance silently, waiting for the object to reappear near Jupiter's path. Analysts debated potential mechanisms behind Atlas' sudden disappearance. Theories ranged from a temporary cessation of its thermal cycle to subtle orbital adjustments using unknown propulsion, or even entering a hibernation phase triggered by environmental thresholds. Each hypothesis carried profound consequences. If the object could self-regulate, generate heat, and manipulate local gravitational fields, then it was operating far beyond any known natural process. The implications for planetary defense were equally startling. If Atlas could actively modify its trajectory, traditional models for predicting cometary impacts became obsolete. Gravitational simulations incorporating its pulsed mass accumulation showed perturbations extending across the asteroid belt, subtly altering trajectories of smaller bodies over months. International task forces began preparing contingencies not for collision avoidance, but for potential interaction with an object capable of autonomous movement, energy management, and magnetic manipulation. Meanwhile, theoretical physicists focused on energy harvesting. The pulsed thermal cycles suggested a sophisticated energy storage and conversion process. Observations implied that Atlas might be using solar wind and interplanetary dust not merely as fuel but as an integrated power system, converting ambient cosmic material into usable energy. In essence, it functioned as a self-sustaining engine, operating autonomously for extended periods in deep space. These findings sparked debates about energy efficiency, plasma dynamics, and cosmic engineering possibilities. Topics previously relegated to speculative astrophysics now demanded practical attention. Even as the scientific and political communities scrambled to understand the phenomenon, public fascination grew.